Hello there, I'm Thomas. This is German America. While flying the Boeing 787-900 to 95, we're going to be overflying from Zurich International Airport back to Zurich International Airport in Switzerland and Lszh. So right now I'm in the cockpit of the Boeing 787-900 and Microsoft Flight Simulator X, Boeing 787-900 of the Quality Wings simulation and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, the displays, and the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb and descent of the aircraft in tens, hundreds, and thousands feet per minute, or the steepness of the trigonometric angles and degrees you can climb and ascend. Also we have the altitude indicator with the artificial horizon, the pitch ladder degrees and the bank angle indicates the angle of attack of the aircraft as it flies in the flight mode to non-zero with the autopilot and the auto-throttle lateral vertical navigation modes. We have also the HSI, the horizontal situation indicator that displays the magnetic heading and track, and also the integrated display of the flight plan. So we're gonna create a flight plan, and you'll see later using the flight management computer. I will input all the data of the aircraft that we need for this flight, and it's gonna create a route or a flight path or a flight plan. It's gonna be displayed in the HSI, and also in the navigation display you would see the horizontal and vertical profile of the aircraft as it flies, and when we connect the autopilot and flight director system panel and the auto throttle, it will follow the flight management computer orders and commands. This gives commands to the flight control computers. Since this is a fly-by-wire aircraft, we have the flight control computers. Also, we have the air data computers. You will see all the functions of the aircraft. We have the FADEX for the engines, the full authority digital electronic control computers that control the engines functions. You can see here in the overhead panel, electronic engine control for the engines. Primary flight control computers over here for the flight control surfaces in the auto position. And also air data computer, other computers. Also every system has its own. The fuel system, the hydraulics, the electric system, the flight controls, remove the flight controls also. So you will see also the navigation display, that displays the GPS position of the aircraft, the inertial reference position. We have the terrain and weather reflections from the weather radar. You can see the terrain around you with red, green and yellow color, the elevation of the terrain of the mountains around you. Also we have the blue for lakes, rivers and sea. You can see how far above the ground the aircraft is flying and see the terrain around you in the horizontal and vertical profile. Also the horizontal and vertical profile of the flight plan. We have also in the terrain map. You can see the airports, the distance they are located from our airport. Right now you can see the GPS inputs from the display. You can see the runways we're gonna use for takeoff and for landing, and the taxiways we can use to taxi the aircraft in the ground from the GPS receivers system. So you can see also, as I told you, the airports where they are located, the port stations, the ADFs, the NDPs. We have the navigation aids, the nav aids, the waypoints which are horizontal and vertical navigation fixes the aircraft. We're gonna have to fly through some waypoints when we're gonna be flying. We're gonna select them using the flight management computer, so I will show you also how to do that. Also you also the outside view of the aircraft, the flight controls, the wings and the aerodynamics of the aircraft that we need to know before flying the aircraft. In the end part you will see the complete flight. So also in the navigation display you see all these things. You see the magnetic north pole and the geographic north pole and the magnetic variations depending on where we are in the world. We have, as I told you, the waypoints. We're gonna use the flight management computer to input the flight plan. So we're gonna select some waypoints to cross through as we're gonna be flying. I will show you then the autopilot flight director system panel over here, the thrust levers, the engines control over here, the thrust levers that we have in the side stick control. So you can see I can control my engines using the side stick here. I have the thrust control, also the control for climbing, for descent, making turns right and left in flight. You can see the engines indication also here, left and right engine, the rotation as percentages, and pressure ratios, temperatures, fuel flow. So I will talk to you about this in a couple of minutes. The autopilot flight director system panel. You can see we have the autopilot engage, disengage switch, LNAV and VNAV, flight level change, this is the airspeed guidance, flight director on, auto throttle left and right, flight change, auto thrust, heading, select mode and hold, bank angle also, vertical rate of climb descent of the aircraft, flight path angle, and also the altitude. So you can see the airspeed, altitude and heading are the same ones as displayed here in the primary flight display, and the HSI you can see we have the airspeed selected right now. It's gonna be 200 knots for after takeoff. Right now the indicated one is 30 knots, and also the altitude, target altitude is the same one, airspeed and altitude, and also the heading here in the HSI you can see 360 degrees of heading, or 0 degrees actually. You can see the ADF left and right, ADF right receivers. So you can see in the primary flight display the airspeed tape over here. You can see the barometric altitude, we are 1430 feet above the sea level. The vertical rate of climb descent of the aircraft is 10,000 feet per minute. You see the needle moving up when we climb, or move it down when we descend. The pitch ladder of the aircraft in flight, 2.5, 5, 7.5, 10 degrees, 12.5, 15, 17.5, 20 for pitch up or pitch down as we fly, the pitch attitude. But also we have the vertical rate of climb descent and the bank angle in degrees, like I don't know, like 20, 30, 45 over here, maybe after maybe 60 degrees. So you can see the radio altitude above the ground level, 39.92 inches of mercury, radio altitude 200 feet. So you can see here we have the range also, the plan. So this is for navigation purposes, to use for the displays over here, for changing the view of the functions of the map display over here with the terrain and the airports, the waypoints. Also you can see the aircraft, you can see the barometric pressure for the barometric altitude in inches of mercury or hectopascals. So right now it's 39.92 inches of mercury, or 1013 hectopascals per square inch. So minimums, radio baro, plan menu, range, weather radar, traffic, terrain, and this is the warnings, cancel, etc, etc. We have also the systems displayed here, later you will see, CDU info, checklist, communication, navigation display. We have the approach for auto land over here, and the word localizer. Also the other side, as you can see, all the displays are the same things. You can see the airports further away in the GPS. Also here you will see later. So you can see also we have the radio altitude. We have a kind of a sonar that transmits radio frequency and receives back and calculates how far above the ground we are in feet when we are in the ground or when flying. Right now we are 2 feet, -2 in this place. So you will see also the flight management computer over here. We'll use the flight management computer to input the data of the aircraft for this flight. So you will see we use this mouse pad here. I have this mouse pad to input the data that I need here in the flight management computer. So if I use that, you will see the purple here display of the mouse pad, just like I do here with my mouse. So you can see here I have the display of every functions I want from the flight management computer commands and also the keyboard that I have a numeric keyboard systems again. So use this mouse pad display, which is like a touch screen. You can see both flight management computers. They give orders to the autopilot flight director system panel again. Thrust levers here. You can see fuel control, left and right engine. We have left and right thrust levers. Also, I will show you some flight controls here. You can see the speed brakes, extend and retract over here. So now it's extend. So you can see the speed brakes like this, which also act as flight spoilers. So you'll see them extend and retract like this. You can see the flaps are fully extended right now also. So we have the control also the flaps position. The flaps extend or retract. They increase or decrease the surface area of the wings. As you can see, they can help the aircraft fly at lower airspeed in approach and landing, for instance. So you can see here flaps retract all the way up. You will see the display flaps up, retract, it says up, then extend back to the position. We need like 5, 15, 17 degrees. Right now it marks. So you can see now the retract, the extend again, 5 degrees. You will see them up, as you can see. So now it's 5 degrees. You can extend them back down like 25 or 30 degrees like this. So you will see fully extended flaps. Over here you can see the wings extend. So I will show you also the flight controls of the aircraft in a couple of minutes. You'll see how I control the flight controls of the Boeing 787-900 using the side stick here. But I have the Logitech Extreme 3D and my computer. Of course, you can see we can move the elevator for climb and for descent like this. You can see climb, descent, make turns using the rudder pedals. You will see later in the flight how I use it. Horizontal trim stabilizer also, we can trim the aircraft in flight. We can make bang rolls right and left and right. So we have full flight control system functional. The side stick deflection is proportional to the yoke and flight controls deflection, but in there is a fly-by-wire aircraft. It has fly-by-wire computers, flight control computers, so it will deflect the way it should be for making Z turns, Z acceleration turns like the Airbus. So it has the flight control computers in flight. It has the auto trim system to trim automatically the horizontal stabilizer and the horizontal elevator. We can trim also manually, so we have the flight control computers channel and we have the manual channel of the horizontal trim stabilizer switch. I will show you now. We have the alternate trim channel. We have also the cutoff switch for the auto trim function of the horizontal stabilizer, so we can use only the manual trim switch in case we have a malfunction of the system. So you can avoid the auto trim. It's this way. You open up this red guarded switch here. So also in you can see the flight control computers again here. This switch. Fly-by-wire aircraft. So you have the side stick deflection, both sides, the captain and the first officer, they move together. As you can see, they're interconnected in flight. All functions, you use the control column for climb and for descent, for moving the elevator of the aircraft, for climb, moving up and moving down. Side stick deflection, just like in the Airbus, the yoke in the Boeing So there is no difference, same function. Rudder pedals, deflection use, the rudder here, left and right turns, rudder pedals, elevator, climb and descend. So you can see the elevator here for climb and descend the aircraft, and also for making turns left and right. The ailerons and the spoilers, we have the control wheel here, turns left and turns right, rudder pedals, control column, and you can see the control wheel. You can see how I control the control wheel like this. You have in the Airbus the left and the right side turn of the ailerons and the spoilers in the air, so you can control the aircraft. So we have also the horizontal trim stabilizer over here. I will talk to you about now. We can trim, as you can see, the horizontal tail with the manual channel of the flight control computers. You can see also some flaps speed here, so you can see the flight control system, how it functions. So you have the elevator over here. So this way you trim the elevator to trim the to pitch the aircraft up in the air, trim the elevator up, pitch the aircraft up, and trim the elevator down, pitch the nose down this way. So you can trim, you pitch the nose up actually this way, and you pitch the nose down to remember more easily. What you need to do actually is to pitch up the nose or pitch down. So you have the head up, the clutter display, you have the autopilot disconnect over here. So you can see elevator trim, left click down, right click. So right click is up the elevator, this click is down, nose down. So you can see how many degrees over here in the display. You have the trim set of the horizontal tail. Right now it's 4.25. It doesn't move because it's automatically from the flight control computers, set for takeoff. Actually, you cannot change it. So you have the horizontal, you can change it in flight after takeoff. So you trim the elevator up and down. So we have, as I told you, also we have the auto trim system, since this is a flight control computer aircraft, fly-by-wire aircraft, just like in the Airbus. You have the fly-by-wire system to control the flight controls, just like when you connect the autopilot and flight director and the auto throttle, or you give the commands from the flight management computer that I will show you in a couple of minutes. You can control the autopilot, flight director system, but also flight control computers in flight and the facilities for flying. If you connect the LNAV and the VNAV function of the autopilot and flight director system panel, so you can see the LNAV and the VNAV function over here. It will connect and control if we need, using the inputs from the flight management computer. So we have the horizontal trim stabilizer here. We have the hydraulic system over here. If we have a failure of the hydraulics, that affects the control of the auto trim system here from the autopilot flight director system panel and the flight control computers. We will have to come down here and open this red guarded switch over here. You can see this red guarded switch here, open from normal to cutoff L2R2. So this is for Boeing 737, 747, 757, 767, 777 and Boeing 787 from normal to cutoff. Just like this, and then you lose the auto trim function. You have only the manual trim channel, nose up and nose down. This is the alternate trim channel. So this is the parking brakes also of the aircraft. Over here we'll show you a couple more things before we go into flight. So after doing that, you lose the auto trim function and you can use only the manual trim, as I told you over here, all the alternate trim switch, so you can trim all the time this way. in flight, trim up or trim down the aircraft. So you use the flight controls this way, likewise. So this is lockwise. You need to have also over here all the flight controls ready. I will show you the flight control for a couple more things. How to control them. Also the outside view over here. Then we go. So you can see the outside view of the aircraft. I will talk to you about the aerodynamics of the flight and the Newton's physics, Bernoulli theory of fluids, and aerospace engineering. We need to know for flying the aircraft for the air transport pilot license. So you can see the surface area of the wings, of the forward wings, hold the weight of the aircraft as the aircraft flies. We have them in aerodynamic chord position. 23% of the Mach is where the maximum aerodynamic lift will occur in the forward wings. Is also the position where the stall. The airflow becomes detached from the top surface of the wings as we fly all the way back, so the aircraft might go fall if we're gonna stall it, so we need to avoid the stall for a given angle of attack and airspeed. Also we have the center of pressure that can move forward or aft. The aerodynamic chord is also the position where the center of gravity of the aircraft transverses over here. So the center of gravity, this is the vertical axis, is the yawing axis of flight for making turns using the rudder pedals. So this is the yaw axis for making left and right turns, yaw axis. So we have also the lateral axis from wingtip to wingtip. It's the pitch axis. The pitch axis is the elevator axis for climb and descent, like this. For climbing the aircraft up or down in flight. So you have the pitch axis, you have the yawing axis that transverses the center of gravity over here using the tail, the vertical tail, and you have also the thrust from the engines, the jet blast propulsion from the jet engines right now, of the Boeing 787.ZX engines. And you have also the longitudinal axis from nose to tail over here, which is actually the roll axis. So the roll axis is for controlling the aircraft using the ailerons and the spoilers, making left and right turns like this. As you can see, roll axis. So you have all the axes of control. You can see also using the Bernoulli theory of fluids, the bottom surface of the wings is more flat. Also we have the flaps extended. So using the Bernoulli theory of fluids, also some Newton's physics, you can see as we are going to accelerate for flight, we're going to have a positive angle of attack like this. So the airflow will be moving much lower below the wings, so we're going to be having higher pressure below the wings, which pressurizes the wings and the weight of the aircraft up into the air when we reach an airspeed of about 220-240 kilometers an hour in takeoff and after. So you can see also the top surface of the wings is more curved, so the airflow is moving much faster above the wings. Using the Bernoulli theory of fluids, we have lower air pressure above the wings, so it sucks the aircraft weight and wings up into the air. So this is the basic aerodynamics. So we have differential pressure between higher pressure below the wings, which pressurizes the aircraft up into the air, and lower speed, which sucks the aircraft weight and wings up into the air. So this is the basics aerodynamics you need to know for flying all aircraft, nearly all aircraft, and the Boeing 787-900 jet aircraft. So you know a couple more things. One more view of the flight controls of the Boeing 787 over here. So you will see over here. So I'll show you the flight control joystick deflection proportional to the yoke. Deflection, both sides, the captain and the first officer, move together. They're interconnected in flight. All flight controls, rudder pedals, control wheel and control column. They don't move independently in flight like in the Airbus. You have the joystick priority and you can take control of either side. left and right. This is moving together unless you have a failure in flight. So you want more view of the flight controls of the Boeing 787 right now over here. So you will see over here this view. You can see my side stick, the Lszh Extreme 3D. So you can climb and you can descend like this. So climb, descend, make turns to the right, make turns to the left. Hope you like this view for making turns. As you can see, right side, left side, control wheel, climb and descend. Also we have the horizontal trim stabilizer that I told you here. This switch, so this switch is mapped here for trimming the horizontal tail up and down to balance the aircraft and relieve the air pressure in flight. So you can see also the thrust levers over here. You can move the thrust levers forward and aft using the control of the thrust over here. So you you can actuate how many percent of thrust you need, like 50%, 60, 70, 80%, 90, 100 or more in some cases. So this is the side stick deflection. You see proportional to the yoke. Deflection on flight controls. So I will show you a couple of view on the outside again. You can see we can climb, we can descend, make turns right and left, aileron, spoilers. So this is all for the flight controls right now. I talked to you about most part. I forgot also to mention the rudder pedals down here. They are interconnected with the tiller, so we have the nose wheel steering control in ground from like until some airspeed like 76 knots, maybe 70 knots. Is interconnected. You have both sides, stick and rudder, vertical rudder and nose wheel, the nose wheel of the aircraft. So it decreases from 76 degrees of deflection left and right side to right to about 7 degrees, about 45 knots until you reach 70 knots in takeoff. Then you have only the rudder, the vertical tail rudder over here for making left and right directional control. So the aerodynamic effectiveness of the rudder pedals is at about 45 knots. Also you have the toe brakes system in the rudder pedals, so you have a couple of more control. So now I will show you the flight control, the flight management computer. I will link with all the data of the aircraft for this flight. That includes the gross weight of the aircraft for flight, that includes the empty weight plus the passenger, plus the cargo, plus the fuel on board, where the fuel is stored in the left and the right wing. In the center tank we have 30% in the left wing tank, 30% in the right wing tank, and 10% in the center tank. So the flight management computer is gonna calculate the center of gravity of the aircraft for takeoff. Also the mean aerodynamic chord position, the Mach, which is 23% of the mean aerodynamic chord, and also where the maximum aerodynamic lift occurs in the forward wing, so the stall will begin in flight. So you need to monitor here in the primary flight display. When you're flying, you will see the stall speed displayed below your airspeed, like with the yellow and red indication down here. You need to avoid have an airspeed and angle of attack that avoids the stall. We have also, this will calculate the horizontal trim stabilizer for takeoff 4.35 degrees. Also the flaps we're gonna use for takeoff 15 degrees. Also we have selected the runway here for takeoff, the runway 14. Zurich International Airport, Lszh in Switzerland. We have the runway length and runway slope, the wind direction and speed, the barometric pressure, the density of the air, the flight management computer. We calculate with all this data. The takeoff space V1, we rotate, and V2 we're gonna have a rotation of 9 degrees or less for takeoff at an airspeed about 130-140 knots. The V1 we rotate, and V2. So we're gonna be having the takeoff. We have the seats, the southern instrument departure waypoints and fixes that include horizontal and vertical navigation fixes for the initial climb of the aircraft and departure from the runway and altitude and speed constraints. We're gonna climb to an altitude like 35, 36, 27, 29, 30,000 feet above the sea level. We're gonna cruise over there, transverse through some waypoints, then we're gonna be descending back to the airport. We're gonna have the top of the descent, and from the cruise level back to like 6,000 feet above this level, we have the Sarasota terminal arrival waypoints and fixes for the terminal approach and landing of the aircraft to the airport Lszh in Switzerland. Again, the runway 14. We're gonna have the stars, and also we're gonna be having the Lszh localizer, the instrument landing system for approach and landing. The Lszh localizer of the runway 14 is gonna having the radio frequencies transmitted from the antennas of the threshold of the runway, which will be received from the aircraft onboard receivers, and will gonna help us align the aircraft with the horizontal and the vertical glide slope, the horizontal localizer and the vertical glide slope. And also the Lszh localizer crossbar. So we're going to be having the Lszh localizer frequency for that of the specific runway and heading. So we're going to be having the magnetic and off-pole heading of the runway 136 degrees for this approach and landing with the Lszh localizer. And you will see also we're going to have 35 to 30 degrees of flaps for approach and landing. But on airspeed about 160, about 170 knots, and also landing gear down on a pitch altitude of 9 degrees or less. So I will show you how I'm gonna create this is the complete flight plan or flight path or route of the aircraft for this flight. So you will see how I'm gonna create the flight plan right now. Control quadrant over here. You can see we have the mouse pad here. I used control the inputs over here of the flight management computer. You can see also the autopilot panel here in the engines, other function. So we have here all the data we need. We have the modes, identity, position, performance, takeoff, approach, and exit status, navigation data, flight plans, load data, traffic control plan, load plan, save plan, save flight plan. So you can see the purple here box moving around. When I move the mouse, you have the identity, Boeing 787-900, GNX engines over here, the Iraq cycle position. So we request to align itself using the inertial reference system, the IRS localizer, and the GPS receiver. So you have the GPS coordinates here. Performance, so we have the gross weight of the aircraft, zero fuel weight and fuel on board, gross weight for takeoff. You will see also we're going to use a reserve fuel, cruising altitude, cost index, center of gravity and cruise, fuel temperature for freezing. So we have the route first of the aircraft. So destination is the same like origin, runway 14 over here. To clear this, you can put on the right one. So we have departure over here and arrival. So you can use the departure runway 10, 14, 16, 28, 32. We have many runways for this airport in the Lszh in Switzerland. So select runway 14. And this is the left side is the seat with other instrument departure waypoints and fixes. So we use the to alpha over here. So we have the arrivals here. You can select VOM 16, VOM 28, 34, ILS 14, ILS 16 over here. The right side is the runways. We can select for approaches, for approach and landing. So we have LS14, we have LS28, LS34, GLS14 localizer, 28 and localizer 34, and the left side is the star. So we use ILS localizer 14 trans this waypoint the Amity, and also using Negria 1 Alpha. The stars is other terminal arrival waypoints and fixes that include horizontal vertical navigation fixes and altitude constraints as I told you. So we have the legs. The route is created with blue, but it's not yet active. So we need to activate the flight plan so we can use it with the autopilot and fly. So we have it's gonna display with white and purple later. It's waypoint from takeoff one by one. As we climb, cruise, then descend, approach, and landing. We cancel and discontinuity. So here's the stars again. Descend, approach, and landing here. So I will activate that by using zero fuel weight plus fuel on board. Over here we have the gross weight for takeoff. The reserve fuel 5% of the total fuel, and we have 35,300 feet for the cruising altitude here for this flight, which is optimum or a little bit higher. So we have the cost index 100%. The fuel freezing temperature in flight minus 37 degrees. It's gonna refuel freeze, so we'll receive later the fuel automatically. So you can see cruising center of gravity 28% for this altitude is weight also. So we press the execute button here. If you use this page, you will see it will turn color from blue to white, and also you see the purple here is active. So it's the first waypoint 136 degrees heading, 250 knots, 1900 alpha, then TRO 250, 1 nautical mile, 3 nautical miles, 5 nautical miles, change direction from 136 degrees to 052, 6 nautical miles Zui, 200, 300 knots over here, 6000 alpha as we climb from takeoff. So this is the flight plan. Negria 26 nautical miles, heading 071 degrees, 301 knots, flight level 22,200. Then with descent we make a right turn, 230 degrees, 12 nautical miles, 320 knots, 11,800. Descent approach again, make 6 nautical miles, 119 knots, 10,400 feet, Zui 276 degrees, 9 nautical miles away from Amiki, 180 knots, 7,000 alpha, ZH 701. Here is the start, the saddle terminal arrival waypoint certificate, 6 nautical miles, 186,000 alpha, VRA 290 degrees, 10 nautical miles away, 185,000 alpha, CI 14 235 degrees, 6 nautical miles, 184,000 alpha. Also then we make a left turn here full line with the runway, 136 degrees, 5 nautical miles, 170 knots, 4,000. Runway 148 nautical miles from Osnum, 136 degrees, 140 knots for approach and landing, 1,430 feet. So this is the complete route of flight plan of flight path. We have also the takeoff ground approach. We have initialized here also the flaps for takeoff, 15 degrees, center of gravity over here, trim. You can use center of gravity trim, flaps 15 degrees, runway request over here, V1 V rotate. So this is the takeoff speeds, V1 V rotate and V2 for this gross weight, takeoff gross weight over here. So we see the legs one by one over here, root legs, and airspeed and altitude, constraints, approach, landing over here. So the flight plan is complete. We have the route, departure, arrivals, alternate, VNAV, progress, FMC communication, hold. We can select a waypoint to hold in flight. Fix, we can set fix rings in the display, legs, navigation radio, so we can tune the ILS localizer for instance, or other things. So we go back in the virtual cockpit over here. We have a few more minutes to see a few more things before making the engine start demonstration. So also the displays what they display, a few things we missed. and the engines function, autopilot flight director system panel. Then we're gonna make a complete flight from takeoff, climb, cruises, and approach and landing. In the end part of the video, so stay in the end part to see the complete flight. So we have the runways here we use for takeoff and for landing, displayed with the flight plan. We use the range here. You can see more airports like this, like in the Germany over here, and France over here, and the terrain map. You can see how we're gonna cruise over here, how we're gonna climb and cross through some waypoints. Range, less range over here. You can see again the flight plan that we created, the purple line, the blue line also. So you can see how we're gonna climb, but you can see the mountains below as we're gonna be flying in front of you. The terrain, avoid them, so also around you. So you can see how far away we're gonna be flying in flight. We have from takeoff over here, make a turn, then descend, approach and land. You can see how far away. Also the center display menu have all the waypoints, not even area over here. So you can see the waypoints here also displayed in this display. You can see Osnam runway. So if we look much closer over here, you can see the runway that we have, the one we're gonna use for takeoff and for landing, the taxiway that we are located, the other runway. You can see the mountains in front of you. So this is the GPS display. So this is the runway we have in front of us, is displayed in the GPS. The runway over here is also displayed from the GPS, the other runway, just like in the original aircraft. So you can use the GPS also sees the mountains in front of you and around you when flying to avoid them, the terrain maps. So we have a couple more things. We're gonna make some changes. The plan here. So you can see the distance of the aircraft from the runway, map centering over here. You can set over here FIR airspace also. On both sides you have the same thing. You can change the range over here again, see further away, the runway heading. So this is for navigation purposes only. So you can see all the data you see here displayed in the primary flight display, the navigation display, all the air data that we have. So this is the air data. You can see the airspeed is from the pitot static, from the pitot dynamic. Actually, the altitude is from the pitot static. Also the radio altitude, tank of attack, the GPS position, magnetic north pole. All these are controlled from the air data computer over here. You have airspeed, altitude, pitot static, pitot dynamic for the airspeed and the altitude, rate of climb, descent, Gulf attack as it flies, radio altitude receivers, also magnetic north pole, geographic north pole. So it's a good thing to have all these things here. I'm gonna show you now the engines, the autopilot flight director system panel, maybe a couple of things. As I told you, we have over here autopilot engage, disengage, the airspeed here, airspeed guidance. You can set whatever airspeed you wish. So it's gonna take a couple of minutes. We have autopilot disengage like this, autopilot engage here, auto throttle left and right. You can see arm and this arm off. So you have climb continuous, auto throttle, LNAV and VNAV, very important. Now you can arm LNAV and VNAV because we have them created from flight management computer. So if you disarm the flight director over here, will disarm also the modes armed. You cannot rearm them unless you have the flight director on. So we have also the heading of the runway over here, 136 degrees for takeoff. We're gonna make a couple of settings, change. So this is heading guidance. Heading hold, altitude over here, thousands. You can set how high you wish. Also hundreds. Hold for localizer, approach frontal, and so this is rate of climb descent over here. You can descend, you see the minus sign, you can climb. The other way, you can level off. So this is plus 3,500 feet per minute. For climb rate over here, you will see all the data displayed like in the autopilot flight director system panel again. Over here as selected airspeed and altitude. So we have also the engines, left and right engine. You can see the N1, which is the low speed status of low pressure compressor into one of the turbofan turbocharged engine, exhaust gas temperature per engine, and 2, which is the high speed status of high pressure compressor into one of the turbofan turbocharged engine, fuel flow per engine per hour, 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 states of the engine. We have also the landing gear, extend, retract over here, alternate gear, auto brakes over here, gross weight for takeoff, a couple more things. So we have the engines indication. I will talk to you about the engines are displayed from the FAREX. As you can see, pressurizer. The engines also provide hydraulic fluid pressurization. So we have the engines, the NX installed in the left and the right wing. The engine we have, each engine has a gearbox with the FAREX. The FAREX are the full authority. This is electronic control computers. One installed Prenzi gearbox, dual channel redundancy, one channel phase, the other solver. Controls, monitors, and displays all the engine data you see in the left and the right wing engine. Display over here in the ACAS and indication control system display all the malfunction display the N1, which is low speed low pressure compressor and turbine of the turbofan engine, exhaust gas temperature engine, N2, which is high speed high pressure compressor turbine of the turbofan engine, and fuel flow per hour, oil pressure, oil temperature, oil quantity, vibration of the N2 states of the engine. Pressurizer 59 states over here, which is used for cabin pressurization of the aircraft. You can see the cabin altitude, rate of climb descent, differential pressure, landing altitude, outflow valves. Also for oxygen regulation in the cockpit, ventilation, air conditioning from the packs. We have the pressurizer from the 59 stage and also from the bypasser. So we have also the FAREX control as we climb to higher altitude. Like 20, 30 or 40,000 feet above the sea level, like 9,000, 10,000, 11,000, 12,000 meters. As we climb higher, the pressure of the air, the oxygen level and the density become less than half than that of the sea level. As we climb higher, also the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. Also the temperature becomes freezing, like minus 30, minus 40, minus 50, minus 60 degrees below Celsius. Below zero, so we're going to be having a different fuel mixer request every second. This is adjusted by the FAREX, the full authority, the electronic control computers. Also, as we descend back to the airport, it's a good thing to have the control of the fuel mixer to the engines. We have also the control of the fuel transfer for circulation from the wing tanks into the engine components and for heating up in flight so we won't freeze. Also the lubricant and oil. We have the circulation of fuels, also the pressure states of the engine. We can control the pressure, over pressure, under pressure. So we are gonna start the engines now. Demonstration. So we start here, the APU. Lights on here. We'll show you. This is the left and right IDZ, the great drive generator, left and right engine. The battery, electric primary flight control computers in the auto position. Heading reference, flight control surfaces. Over here, down FD door, down power, passenger oxygen. Over here, rammer turbine, left and right engine driving. In the auto, we can turn off. You see what happens. Also electric C1, C2. So we turn back on and to the auto. The primary in demand. We have wing and engine ADIs over here. We can control the ADI system. We have the lighting system of the aircraft and the windshield wipers also. Down here we have the recorders. Up here the cargo and APU fire control, electronic engine control for the engine, left and right engine auto start also. Fuel jettison, we can dump some fuel in flight. We arm the switch and select the nozzles to lose weight and make an emergency landing. We have the fuel booster pumps and the crossfeed valve. If we turn it on, you can feed either engine with either pump or either tank. So this left wing, right wing, and center tank fuel booster pumps. You can also balance the fuel using the crossfeed between left and right. We have also pressurizer, air conditioning, ventilation, oxygen, and cabin pressurization over here. Climate descent also. So this is very quickly in summary what we need to know. We have also the display of all controls here for all systems, digital format over here very quickly. So you can see over here hydraulics, APU is running, oxygen, liquid cooling, electric, as I told you, left and right, IDZ 120 to 100 volts, 400 Hz frequency, APU is running, Lszh over here, and main battery, voltage and average, also the APU battery. So you have hydraulics, where the hydraulic fluid goes with system used, left engine, right engine, electric C1 C2 5100 psi system, the quantity, and set of valves also. Fuel, you can see left and right wing, center tank, 11,000, total 33,400, low high pressure fuel valve, left and right engine over here are fed from the center tank, the green line. APU is fed from the left wing using this motor. Crossfeed valve is off, but if we turn it on, you can feed either engine with either pump or either tank. We have a failure or balance the fuel between the left and right wing. The crossfeed valve, we have the fuel minimum fuel temperature over here, below which the fuel will freeze -37 degrees, and the fuel temperature right now, so we recirculate the fuel in flight automatically. The air pressurizer from the packs, left and right engine, doors are closed, cabin pressurization, gear, temperature of the brakes, pressure of the tires, flight controls. Here you can see all the flight controls, movement over here, the tail for climb descent like this, and for making turns. So you see all the flight controls are functioning, there is no failure. Maintenance, F is over here, F is display maintenance, display. And we have the last thing here, checklist before going for flight, normal menu, what to do before takeoff, after takeoff, descent, approach, and landing. So we have the navigation display again. We're gonna turn off both engines over here, controllers to the off, left and right engine like this. So you see the fuel is off, fuel control, left and right engine. So you can see here so we have the engines off. We go in the overhead, auto start both engines, left and right over here, auto start to the on position. You see the yellow reconfiguration. We have pressurizer right now from the APU to supply pressurizer for the engine start above 20%. We're gonna be having the fuel flow for the engine. So you can see we still have pressurized air over here, so we can start the fuel flow right now very quickly like this. Fuel control, left and right on. So we have the auto start kicking in, auto start left and right engine. So we have above 40%, keeps roaring. You will see the systems going off right now, and we have the running engines over here, both sides with green. So flaps for takeoff over here, flaps for takeoff, parking brakes off, advance the thrust levers, and going for takeoff like this. So we have the runways open for us for takeoff over here. We use the tiller for steering again. So it tucks into the runway like this. So align with the tiller again, like this. Advance the thrust levers, take off, go around over here. And align with the rudder pedals. So we have the takeoff, go around here, thrust, full thrust. So we have 80 knots, 100, 110, V1, we rotate over here. So we rotate like 9 degrees slightly, as you can see. And we climb, we have the takeoff of the aircraft. We can leave the flight controls off if we need, there is no problem. It keeps flying by itself, it's a fly-by-wire aircraft. We don't need the autopilot or flight controls by itself, as you can see, keeps climbing. So this is the controls, all what you need to see over here. You can see the airspeed 190 knots, the stall speed, the wind direction and speed here, the rate of climb. We are 1,700 feet, 2,000 feet above the ground, but 3,800 above. You can see 2,200, 3,900 above the sea, 2,400 above the ground, climb with 4,900 feet per minute. The pitch attitude like 20 degrees, the stall here, we can pitch the aircraft down to increase the airspeed. You can see how far above the ground we are right now located. We are almost 3,000 feet above the ground. You can see the terrain below you and in front of you, around you, the flight plan. So you can use a little bit more range over here. You can see also the autopilot and the engines indication as we're climbing. So we have a better view now of the terrain in front of you and around. So this is the climb of the aircraft, and we have landing gear up also. We have the positive rate of climb. So landing gear up, you can see the Switzerland around us, the lakes over here. So we have the Swiss Alps, and we make the turn now. Turn to follow the flight plan. Also use a little bit less flaps over here. Need to increase the airspeed. So we cross 9,000 feet right now over here. So this is the runway over here. We're gonna make a turn. We can leave flight controls off, as you can see. We're making the turn here. This is the beautiful view here of the aircraft. We need to make the turn. Also to follow the flight plan over here. So we need to align the flight plan. So this is the view of the cockpit just after takeoff, as you can see, of the Boeing 787. And we have like 12 more minutes for going back to the airport. You can see all the air data here. can also set the other side here. For climbing also the aircraft to the flight one over here. So this is a beautiful view here of the galaxy, the Switzerland here, the Italy, the Swiss Alps, the lake, also the Germany, my homeland, Bayern Munich in front of you, and the France. We're gonna make a turn here for alignment with the flight plan, like this, and then a second turn as we climb. So we need to align with the flight plan. Keep heading this way. So we have the Zui, which is actually here to the left of us, but we're gonna override that and make a turn here and align again with the flight plan. Align as we climb. Hope you like the view. So we're gonna make the turn now for going back to the airport, like this. I'm gonna make a turn, as you can see. We keep climbing. 30,000 feet. We have the lake in front of us. So we're gonna be flying a few seconds. You will see the flight plan. We are aligned now. The flight plan over here with this line. We need to follow. And we're gonna be making a turn now. Over here. Right turn, as you can see. There is a little bit right rudder. So you can leave again the flight controls off, like this, as we're taking the turn over here. You can see we have the Bayern Munich, Germany over here. 787 view. The France over here, the Italy in this side, and the Switzerland here, the Swiss Alps, and beautiful lake and mountains. So keep turning. 22,000 feet. Overflying out the Swiss Alps, so a bit more tight turn. We're gonna be having also all the handrails in a couple of minutes, couple of seconds maybe. So this is us, 22,000 over here, and we're going back to the airport, as you can see. So we retract the flaps, and we have the handrails right now, so you can see. Retract the flaps over here. We are almost 33,000. feet. Beautiful view, the lake behind us. So this is the vapors from the aircraft, from the Boeing 787, as you can see. Beautiful view, the crescent also. So keep climbing over here. So we need to turn back to the airport right now, as you can see. So we start the descent now to the airport to retract all the flaps. Increase the airspeed like this. So we need to see the descent over here. So we start the descent now. Descent rate. And we have 6 more minutes left for approach. You can see the airport over here. Have a nicer view of the cockpit now. So we have the hover street, also idle thrust over here, and some speed brakes. As we are descending. This is the navigation displays here. The airspeed like this, into approach like this over here. So we make the turn now for the approach and landing. You can see we are aligned with the waypoints, so we have 4 more minutes. Descend even further. So there is no problem actually controlling the aircraft with high altitudes like this. You can increase the rate of descent. You can see how we're making the turn for approach and landing over here. So we need to be aligned over here with the flight plan again, and also the ILS localizer. So we are into the runway, heading over here, a bit to the left, a few more flaps over here for approach and landing. So we are into the runway direction. You will see how we approach and land over here, like this. So we have full flaps for the touchdown, for landing. So you can see we have also the Lszh localizer over here. We need the information of the Lszh localizer, instrument logic system, and we have a couple more minutes for approach and landing. So add a little bit more thrust. We have some wind gas, some side wind and crosswind, as you need to know. It changes the direction of the aircraft, so we use a little bit rudder pedals to align with the runway, and a little bit of flight controls yoke. So we have the airspeed that we need. So we align with the runway, wind gas, side wind. Also increase the rate of descent now for approach and landing. Idle thrust also, because we are almost ready for the flare of the aircraft here. Increase the rate of descent. So we're going to be having the flare now, a couple of seconds, as you can see. So we flare. This is a flare, touchdown. Beautiful flare and touchdown, parking brakes and thrust reverse. Idle thrust with thrust reverser over here, as you can see.